Good morning. My name is James Simon, and I'm here to bring you up to speed on the Vehicle-to-Cloud Communications project here at Automotive Grade Linux. We'll go over the working group that's involved in the project, a little bit of an introduction about myself, then the definition and scope. I'll provide a status update. We'll talk about some potentially funded project areas, and then discuss the calls for assistance and ways that you can get involved in the project. I'm the design lead for the working group. Walt Miner is the automotive community manager. Richard Elberger is an automotive stakeholder. Scott Murray is an automotive stakeholder. And Megan Knight is the AGL program manager. A little bit about myself. My name is James Simon, and I am the technical strategy lead for connected vehicle platforms in the Amazon Web Services Automotive Business Unit. I've been there since October of 2021, and I lead the definition of technical strategy for ourselves and advise our customers on connected vehicle platforms. My primary focus with automotive has been vehicle communications, as well as hybrid electric features, infotainment, and overall connected services design. I also managed the design at my previous employment for the entire vehicle-to-cloud communication system, designing an always-on connected services communication protocol using MQTT and Protocol Buffers. The project definition for the vehicle-to-cloud communications project is that its intention is to produce a prescriptive specification for the production, consumption, and orchestration of messages between connected vehicle devices and the cloud using MQTT protocol buffers, and is inclusive of capabilities for vehicle identity, security, and system architecture. The message definitions in this project are intended to align with message definitions in the Cuxa.val gRPC project. The scope includes the documentation of recommended best practices for MQTT version 5 based vehicle communication patterns, including topic design, protocol definition, sequence diagrams for specific use cases, identity, and message services, including the generation of messages and providing unique IDs for the messages themselves as well as the vehicle. Testing and simulation framework, and cloud assets for vehicle-to-cloud communication. The artifact locations are noted here. You can access them from these links. It includes a Confluence page that provides much more definition about the scope of the project, as well as the repository where the vehicle-to-cloud communication project is stored. So by way of a status update, the bulk of the informative sections of documentation have been completed, including the basics around MQTT and device provisioning, general messaging and for publication and subscription. There's a proto definition with object names conforming to the vehicle specification object naming conventions. It's been created for HVAC, cabin preconditioning, and is intended again to align with the POC for using gRPC. In addition, topic naming, message orchestration, design, and documentation have all been completed for the same, as well as for a general message header and location services protocol buffer files. In terms of associated project work with potential funding, we are looking to develop a vehicle identity service, this being a programmatic and secure method of producing a vehicle identity that doesn't expose the VIN in plain text. This is a sort of requirement for compliance with gRPC, with GDPR and other privacy laws and regulations. We're looking for a UUID service to be developed to ensure that messages have non-repeating IDs, and this is largely a matter of diagnostics and support, but it is important for vehicle-to-cloud communications to have a unique ID service. We are looking to embed the protocol buffer library if it doesn't already exist within AGL and the distributions. We need a reference telecommunications client. This is a client that would receive messages from application services, create and publish the MQTT message using the protocol buffers, and would also receive messages on behalf of applications coming from the cloud and then route them to the appropriate applications. It's recommended that these be done in C or C++ or Rust, just making sure that it can be leveraged in the widest possible embedded environments. And finally, reference cloud services. We're looking for implementations of AWS IoT and other cloud services to show the orchestration of messages from the cloud side. Our final call to action is that we need help reviewing the content in the repo as already produced and adjusting diagrams and other content as necessary. Again, we need help producing that reference implementation in C, Rust, and Python. Help creating a testing and simulation framework. This would be something that would be capable of generating messages and delivering them, and then validating that they were able to be serialized and deserialized appropriately and have all the right content. Help creating security tests to validate the security of the vehicle identity and the vehicle to cloud communication scripts. We need to create a vehicle identity API for AGL. This was talked about on the previous page. And then help aligning the specification message objects to the vehicle signal specification. So if anybody's interested, you can feel free to interact with the repo, to take a look at the Confluence page, and to contact any of us from the working group. That's all for my update. I appreciate you taking the time to listen. Please feel free to reach out, and have a wonderful rest of the all-member meeting. Thank you very much.